This unit is mainly going to talk about factoring. We're going to learn what that means and how to factor polynomials and numbers. Before we do that, we are going to define factors and multiples. And sorry about that, that's spelled wrong. So we need to make sure we understand the difference between factors versus multiples. So a factor is basically a number that goes into something. So for example, if you were breaking 20 into a multiplication problem, you could do 2 times 10, 1 times 20, or 4 times 5. So we would say that 1, 4, 5, 2, 10, and 20 are all factors of 20 because they all go into 20 evenly. A multiple is opposite, so a multiple would be the actual number that you break. So it's the number that you divide, or your starting number. So for example, if you were to list multiples of 4, 4 times 2 makes 8, 4 times 3 is 12, and 4 times 4 is 16. So those are all what we call multiples of 4. A good thing to remember is when I think of multiple, I think of M for more. So multiples are going to be more than your starting number. Factors are going to be less than your starting number. If you don't remember what prime means, it's basically a number that can't be broken down. So the only thing that goes into it would be 1 or itself. In high school, we refer to this as a prime number can't be factored. That's how we say it in high school. Composite is obviously opposite. So a composite number can be broken down or it can be factored. So there's something else that goes into it besides 1. So some examples of prime numbers would be 2. Nothing goes into 2 except 1 and 2. 3, 5, you have 11, 7, 23. Those are all prime numbers. Some composite numbers would be basically any even number besides 2. You could have an odd number like 9 or 21 because those can break down into 3 and 3 and 3 and 7, so they're composite. Anything that ends in 5 besides 5 itself, like 1005, that's going to be composite because you can divide it by 5. So just little tricks to know when something's divisible. When we get to our actual factoring, these are going to come in handy. So what we do with diamond puzzles, you're going to find yourself repeating. So I like to teach my kids diamond puzzles before we actually go into factoring any polynomials. So it's really easy. How it works is you get 2 random numbers. So let's use 3 and 4. All you're going to do is multiply them and your product goes on the top. So you put 12 up top. And then what you're going to do is add them and that goes on the bottom. And that's it. That's how diamond puzzle works. So if you look at this one, 8 times 1 makes 8, and 8 plus 1 makes 9. So I would call this a level 1 diamond puzzle. This is pretty straightforward and it's easy. However, 1 and 2, I'm not giving you both side numbers, so I call them my mystery numbers. I'm not giving those to you. I'm only giving you the product and one of the numbers. So you have to think 5 times what makes 10, and that thing is going to be 2. Now that you know this is 2, you can do 2 plus 5 and you get 7. Number 2 is opposite. This time I gave you the sum. So you have to think 2 plus what makes 8? Oh, that's 6. And then 2 times 6 makes 12. So that's why it's called a puzzle, because you get certain pieces, you have to find the other pieces. So these what we call level 2s. And then these are the level 3s. These are the hardest. You're given the product and the sum. And that's it. You have to figure out the 2 numbers that satisfy both of these. So the way you want to approach this is list all the ways to get 40. So you could do 1 times 40. You could do 2 times 20. You could do 4 times 10. Or you could do 8 times 5. So those are all the ways to get 40. The only combination that makes 14 is this one right here. So those are your mystery numbers. So probably have already figured out for 15, the numbers are going to be 5 and 3. And that's it. That's how a diamond puzzle works. So we're going to kind of go into our factoring mode now. Now that you know how to do a diamond puzzle, we can switch gears and focus on factoring. So we're going to get a situation. So Riley has 14 pieces of candy. Leah also has candy, but she only has 7. Rachel has 28 pieces, and Gwen has 49 pieces. And what each girl wants to do is they want to share their candy with their friends. So Riley has 14 pieces of candy. She can't give 10 to one friend and 4 to another. That's not fair. So they have to be fair. That's basically the rule. So Riley could share with 2 friends. She could share with 7 friends. She could give all the candy to one friend, even though that's not really sharing, but she could give it all away. Or she could share with 14 friends. So these are Riley's sharing options. What you want to do right now is pause the video, go through and write the options for Leah, Rachel, and Gwen, and then just unpause when you're done and see if your answers match mine. You came up with. So Leah could share with 1 or 7 people. Rachel could do several options. She could have 1, share with 2 friends, 28 friends, 14, 7, or 4 friends, and it would all be able to be broken up evenly. And Gwen's options would be 7, 1, and 49. So the question to you is, besides 1, so like 1's not really sharing, so I'm just gonna kind of ignore 1 for right now. What do they all have in common? And that number would be 7. So if you recall what factor means, a number that goes evenly into another number, it's not a coincidence that 7 goes into all of these. That's the idea. When you split something into groups and you want it evenly, you're basically looking for a factor. 7's actually a special factor. It's a common factor, so they all basically have 7 as an answer. And it's also the largest factor that they have in common, and that's kind of where we're going with this. So we're going to take this concept of the biggest factor that 2 things or 3 or 4 things have in common, and we call that the greatest common factor. And that is the most important part when you're factoring a polynomial. So what we're going to do now is we're going to list factors of 36 and 45 without the whole word problem scenario. So remember, factor is a number that goes into something. So you always want to start with 1. You always want to start with 1. And then you have to ask yourself, does 2 work? 36 is even, so 2 will work. And then you have to go with 3. If you don't know the 3 trick, it's pretty awesome. What you do is you add the digits in the number. So I'm going to add 3 plus 6 together, and you get 9. If 3 goes into that answer, then 3 goes into 36. And so obviously you can do 9 divided by 3, so 3 is going to be a factor. If you don't know, 4 does go into 36 evenly. 5 is definitely not, because it doesn't end in 5 or 0, so 5 can't go in. 6 does. 7 does not. 8 does not. 9 does. And I'm going to freeze right here because I noticed that 9 times 4 gets 36. So what I do is I call this mirroring. Once you list 2 numbers that multiply to make 36, you can actually use these other numbers to get the rest of your factors. So all you got to do is do 36 divided by 3 and you get 12. And then you do 36 divided by 2 and you get 18. And 36 divided by 1 gets you 36. So that little mirroring trick saves you a lot of time. And you'll always get to a point in your list where 2 of the numbers you wrote multiply to get your answer. And that's when you start mirroring. So let's do it again with 45. 1's going to go into 45. 2's not, because it's an odd number. If 2 doesn't go into 45, then no even numbers can go into it. So even numbers don't go into odd numbers. So that leaves us with 3. If you add 4 and 5 together, you get 9. So 3 is going to work. 4 is out. 5 definitely works because it ends in 5. 6 is out, 7 does not work, 8's out, 9 does work, and now I realize, oh, 5 times 9 is 45. I can start mirroring. So 3 times 15 and 1 times 45. That's all your factors of 45. That's nice because you don't have to keep going to like 10, 11, 12, 13, 14. You don't have to keep checking all those. You can just mirror and get the rest of your factors. So the next question is, what is the biggest factor in both of these lists? So they do have 1 and 3 in common, but they also have 9, and 9 is the biggest number that they have in common. So we call that the greatest common factor, or GCF for short. Now, I don't write what is the greatest common factor of 45 and 36. Instead, we show it like this. And that's when you have to realize, okay, Mrs. Stoltz wants the GCF, and that is 9. So we just kind of use that notation for short, to shorten things up. First things first, I don't know why this says 15 and 30. We want to change that to 24 and 80, because that's the example you're supposed to do. Your task is to find the greatest common factor of 24 and 80. We could make a list, so I could list all the factors of 80. 1, 2, 4, 5, and so on. It's going to be a lot. Or we can do it a quicker way, which I call the ladder method. It's really easy. You just list 24 and 80. You draw your first ladder, as I call it, and you just have to think of a factor of 24 and 80, such as 2. 24 divided by 2 leaves you with 12. 80 divided by 2 leaves you with 40. And then you draw your ladder again. So something that goes into 12 and 40, for example, could be 4. And that's going to leave you with 3 and 10. We're going to stop laddering now because nothing goes into 3 and 10. The things that you divided by were 2 and 4, so those get circled. Multiply them, and there's your GCF. Let's say that you went off on a different way, and you decided to use 8. You said, oh, 8 goes into both of these. Okay, that still leaves you with 3 and 10. So 8 is basically the only thing you divided by, so that's your answer. It doesn't matter what you divide by, you're going to get to the same endpoint, and you're going to get the same GCF at the end. So pretty nifty trick.